Let us explore three powerful machine learning techniques: decision trees, random forest, and gradient boosting. Decision trees make decisions step by step. Random forest combine many trees for better accuracy. And gradient boosting improves models by learning from earlier mistakes. Together, they build smarter AI predictions. Don't forget to like, share, and subscribe. Decision trees are the foundation of many AI models. They work like a flowchart, asking questions at each step and slipping data into smaller parts. Each slip helps the model make smarter and clear predictions, just like how humans make decisions step by step. Here is how decision tree work. Each internal node asks a question based on one feature. Branches represent the possible answers, yes or no, leading the data in different directions. Finally, leaf nodes give the result or class prediction and completing the decision process. Here are the key concepts in decision trees. First, splitting criterion. It decides how the data is divided using Gini, entropy, or mean square error. Next, the depth. It controls how complex and detailed the tree becomes. And finally, overfitting, where the tree learns too much from training data and performs purely on new data. Here is an example of a decision tree. It starts by asking, is the income above 50,000? If yes, it checks the credit score. Is it over 700? If no, it looks at the person says, is it under 30? Based on these questions, the model predicts whether the customer will buy or not buy the product. Decision trees offer many advantages. They are easy to interpret and visualize, making them simple to explain to anyone. They handle both numbers and categories without heavy pre-processing, and they work well even with raw or incomplete data, saving time and effort in data preparation. While decision trees are powerful, they do have limitations. They can easily overfit training data and struggle with small data changes, leading to unstable results. Also, since they use a greedy approach, they miss better overall decision paths and fail to find global best solution. Random forest is a group of many decision trees working together. Each tree makes its own prediction and the final decision comes from the majority vote. This teamwork approach makes the model more accurate, stable, and less prone to errors like the wisdom of the crowd in action. Random forest works by creating many decision trees. First, it takes random samples of data and features. Each tree learns independently on its own data. Finally, all trees combine their results through voting or averaging to make one strong and accurate prediction. Random forests have some clear advantages. They give excellent accuracy for both classification and regression. They handle noisy data very well and reduce overfitting by combining many trees. They also show which features are most important for making prediction. Even though random forests are powerful, they have some limits. They are harder to interpret than a single tree, need more memory and processing power, and take longer to make predictions since many trees are used together. In finance, random forests help banks predict loan defaults. They analyze credit history, income, spending habits, and other factors to assess risk. This helps banks make smarter lending decisions and reduce chances of loan failure. Gradient boosting builds trees one after another. Each new tree learns from mistakes of previous ones. It's like a team where every member improves on what the earlier one missed, step by step, making model more smarter and more accurate. Gradient boosting starts with a simple model. It calculates the errors and trains a new tree to fix them. Then it adds new prediction to improve results. This process repeats again and again until the model stops getting better. Gradient boosting has three key parts. The learning rate controls how much each new tree improves the model. The number of estimators decide how many trees are built, and tree depth balances accuracy and overfitting by keeping trees shallow. There are three popular grading boosting tools. XGBoost is fast and highly optimized for top performance. LightGBM works best for large and complex datasets, and CatBoost easily handles categorical data with minimal preprocessing. Gradient boosting is powerful because it delivers exceptional accuracy, often beating other models. It captures complex relationships in data that simple model miss, and with built-in regularization, it reduces overfitting and improves overall performance. Gradient boosting is powerful, but it has some limits. It needs a lot of time and computing power to train. It is sensitive to settings like learning rate and tree depth, and it is harder to interpret compared to simpler models. Gradient boosting is used in many real-world applications. It helps predict customer churn, detect fraud in real time, forecast sales trend, and even optimize online ads by predicting which ones people will click on. Here is a quick comparison. Decision trees are simple and easy to interrupt but may overfit. Random forest balance accuracy and stability. Gradient boosting gives the highest accuracy but take more time and it is harder to interpret. So choose based on your needs and goals.